So one important one for the VGG16 is we have this one. Instead of 7x7 crossover channel, we use 3x3. But how many 3x3？ 去年我考这一题，一个7×7用几个3×3来取代？ It's not difficult. Actually, it's not difficult because there's 7x7 and one 3x3 will reduce boundary, right? Your 3x3 filter, so you lose the boundary, so become 5x5. And one more loose boundary. Boundary is the left, right, top, bottom, so become 3x3. So if one 7x7 filter can replace by 3x3. So they reduce from 49 become 27, but that's only for one map, and you have many maps, so it will reduce a lot of parameters. Okay, so as I understand, VGG16, the total parameters is less than ArcNet. Sorry, that's right, less than ArcNet. ArcNet is five layers. VGG16 is 13 layers. However, the total number of parameters VGG16 is less than ArcNet because they use 3x3 filters. Okay. So here is the other example. So this 5x5, you use this is 7x7. Sometimes if you use 5x5, so 5x5 become 1. You need to use 2 3x3 instead of 1 5x5. And this parameters, your 5x5 is 25, 3x3 is 9, 9 times 3 is 9 times 2, sorry. 9 times 2 is 18. So still the total parameter is less than 25. Okay. The second issue is the same VGG. Okay. Suppose you have one image for each one image, you do different kind of scaling. 你把它放大放小 different kind of scaling. And then you do crop. Just based on the center, you crop. So input image size is the same, or 2x24. However, inside the image, the target size is different. 你把原来这张影像做不同 scaling， 然后再把 crop， 然后再输入。So suppose there's only one image. If you do 2 different types of scales, so it becomes 3 images. So you input 3 times, and you got 3 results. Okay, and then they do the average of the result, and that's become your final result. And they prove this result is better than only one image input. I mean for the training. But tester is only one image. But sorry, I'm wrong. Tester is, you can do one image, it can do the same 3 images and get a result, do the average. Okay, so back to here, for the training, for each image, they have 3 scales. So original scale and the other 2 scales. And then 3 scales, but you do crop. So the same image size and input for the training. And the loss function here, because your purpose is to classification, and you have 1,000 classes. So you do classification. Because to classification is easy. You just use the cross entropy. Y log Y prime. Y log Y prime. And Y is the label. Okay, so even though it's summation 1 to 10,000, okay, but your input is only select. So suppose right now we classify dog. So this only when dog here is 1, others are 0. But this is not good. This kind of loss function is not good. Okay, so RetinaNet say this is not good because you ignore the other rest of the not the same class. You should include that one. 哦，你那个 RetinaNet 说你不能只这样子做，因为这个只是你虽然有1000个嘛，可是你每次输入是狗是一类，那1000个只有一个1加到0啊，所以实际上只有一个1而已，那这样不对。你应当是还要加上其他，就1000个都要加，它的那 score 你都要加回来。这结果当然是更好，当然是比这个还好。所以这个不能只有是那个 class， 还要不是那个 class 的，你要把的那个 score 你要把它加回来，所以它会加上一个1减 y 嘛，那这1减 p 这样子。那这个是什么 ？This is a probabilities meaning you input this one input one image and what kind of class is class J or not? So this is a kind of like a likelihood and label. And B is the batch size. Batch normalization, batch size. So this is the mean you divided by batch size. So this is a mean square, cross entropy. This is cross entropy. Okay, and this is a gradient descent. So you just keep improving your weight. Okay. So that's for the training. Okay. For the test, you can either just use one image for the test, or you can use the same 3 different scales and input, and you got 3 results, and then do the average, and then you use your final result. And then prove this result is better, this kind of a result is better than the other one, only single input. So 它会就算出来平均这个会比较好这样。但是事实上 after this paper I did not see any other paper do this way. But is this better? I'm not sure. I'm not sure whether this will be better. But it will take time. 这花比较多时间这样。但是this is also a method. Okay. One more thing is here. So the parameters. So what kind of parameters are important during the deep learning? The first one is the pre-process. So your input will be original image. That's one way. You can just input original image. But usually this is not so good. The other way is they do is this one. What is this one? This is for each image, you summation all over the pixels and find the average pixel value. And then each pixel you subtract with that pixel value. So become normalize this one. Do normalization. It's the other method. But as for training, okay? So for training, let's say again, for each individual image, you sum over RGBs, each one RGB separate, and you summation the average value, become average value, and each pixel is subtract with the average value. So it's kind of a normalization. This one method. Okay. The second method is suppose you have 1,000 images. For each pixel, each pixel. You summation over 1,000 images and got an average value. The second method. But which method is good? Actually, I'm not sure. I don't know. But first method is easy. For individual, first one is in the normalization for individual image. The second is all over for each pixel. And you have 1,000 training data. So each pixel, they do the average over 1,000 images. And you got the average pixel value. And then the input, each corresponding pixel is subtracted with the corresponding pixel. 所以两个方法，一个是每张是独立去做 normalization， 第二个方法是整个 training data 去做 normalization。这两个方法都有人做，结果都比较好。那至于这两个方法哪一个方法比较好，我真的不知道，因为都有人做了。OK， 没有去比较了，但是这个要做了。bias。OK， and then you should consider about batch size. You should consider moment. So this one from here, moment, and then learn value, just learning rate. Both are important. And usually moment value they give very high, 0.9. 就 moment 他们事实上 moment 事实上他们都给满，就是值不会很低哦，是 0.9 是对的。OK， 那这个 regulation 我忘记了，忘记哪一个 regulation 这我忘记哪边。那 learning rate, okay, is very important. So initial learning rate, and all you want to do adaptive learning rate. Okay. But in reality, you should do adaptive learning rate. I mean, have an initial learning rate, and then after 10 iteration of Epicor, you will change the learning rate. Sorry, actually, I said you should do adaptive, not. Sometimes many people use initial, and then after several Epicor, they do the other learning rate. But the other learning rate is probably 1 of 1,000， 就是大概1%小，会一下变很小这样子。Or you can use adaptive learning rate, up to you. Okay. And drop out always is 0.5， 这是对的啊。OK， 那 Epicor 要几个 ，POC 要几个，我不知道哎，有时候很多。OK， 所以这提供你参考，但是这个还蛮重要的，提供你参考一下。这边这个比较没什么，所以是。Okay, the next one is for the MLP neural network. You want to fully connect it, or you want to do the fully convolutional. 所以你要用一般的全连接方式，或是要用那个convolution 的方式，这两个都有人做。那 I forget probably this paper only this VGG probably only use this one, but later on people improve this one. 这边 paper 好像没有提到这个啊，那后面有人改良加入 convolutional 这样子。那 why convolutional? Because convolutional, a good one is a convolutional can input any image size. Connected, you cannot change the image size. It's fixed because here fully connected, number of fully connected is fixed. So your input is fixed. And for convolution, you can input any image size. 那这个例子不大好了哈，因为这个例子通常是 因为这是属于 encoder。那 encoder 基本上没有 bounding box 嘛，它只做分类用。This is not good example. Sorry， 那边学生弄没有，我没注意。So this is not good example. Usually because the backbone is only for classification, so your input should be only one target, one object, and you try to recognize this target belong to which class. Okay, so this is wrong. Should be only one target. But if you input it two targets, two objects, that's a union bounding box. So that's first RCNN case. Okay, but back to here. So which one is better? If your input image size can want to be any, you should use convolution. Okay, but it doesn't mean if both input are the same, it doesn't mean this will be better than this one. Don't misunderstand this one. 不要被这个搞混哦。Don't misunderstand. 不是说 convolution 什么结果都已经比 fully connected 还好，不是哦。Convolution purpose is we don't want the input image size is limited, so we use convolution. 就这样子。But if your input image size is fixed, okay, you can use either one. But which one is better? Actually, I don't know. 不知道，因为我没有去比啊，我没有去比，但是并不代表这个不好哦，这个结果是好，所以你会发现到目前为止还是很多人用 fully connected 的、哦、后面这边，只是 recently people still use fully connected because this result is good, but they don't use 3 layers, probably they only use 2 layers， 他们只用2层而已，就2个连接这样子哈 ，OK。因为3层太那个什么参数太多了。And this one is we have a this is an example that you know. Okay, so suppose your image has 3 by 3. Okay, and if we do the flatten like this one, so how it works? 就我们是2D 的嘛，那如果用1D 的观念来看的话，那这个是怎么一回事 ？So this is the position value 就是那个一个 node 1, 2, 3 until 9. So this one. And this output, because your filter is 2 by 2. So suppose this filter. So from beginning, you put here. That's meaning here is a 1, 2, 4, 5. So you're connected only, your connection only 1, 2, 4, right? 4, 5. So the parameter 1, minus 1, minus 1, 1. These parameters. So only connected. So the result is here. And we shift. So here become 2, 3, 5, 6, 2, 3, right? 2, 3, and 5, 6 connect with this one. And you do convolution and use after linear combination, this is your output. So after this one, your output is this one. So this is an example for convolution. Okay. And also we call shear weight here. So compare with convolution compare convolution with the connected. So connected actually is meaning your filter image size is the same as your your input filter size is the same as your image size. That's fully connected. So here, sorry, 它这个画的不是很好，这应当是画错了，这应该是9宫格啦。 这可能画错了，就是说 connected 就是 your filter size is exactly the same as the image size, so you fully connected. You got a result. You got a result. 这样，就这样啊。这个做的不是很好，抱歉。好，我们再继续。这你再自己看到，这个是整理一下。后面 ，OK， so that's for the AXNet。你看 AXNet。那我们继续看，看 ResNet。So we talk about ResNet here. But in this lecture, I will mention about GoogleNet. GoogleNet here. Okay, so we just finished the XNet. Oh, sorry, we finished XNet, we finished VGG. And here we talk about ResNet. But before ResNet, because ResNet will combine information about VGG and the GoogleNet. So in this lecture, I also mention you about the GoogleNet here. Okay. And ResNet is the important one is because we're shortcut. We're shortcut here. And the other issue is that we call bottleneck. ResNet has several important things. One is identity. Identity is a shortcut. And why we need shortcut, I will explain this one. And the other one is that bottleneck is important. Okay. And bottleneck has one important thing is that 1x1 filter. We talk about filters 3x3. We talk about 7x7 or 5x5. Here, one important one is 1x1 filters. Sorry, 1x1 filter is important. So GoogleNet Inception use 1x1 filter. ResNet use 1x1 filter. So that's why we do GoogleNet. There's two paths. There's Google and there's Microsoft. Okay. So ResNet based on deep network. They also include some information about GoogleNet. One information is a 1x1 filter. Okay, from GoogleNet, from Inception. Okay. The second one important one is batch normalization. Batch normalization. 我们之前 previously we did not talk about batch norm. Here they mention about batch normalization here. The third one is they talk about average pooling. Before we only do the maximum pooling, but here they talk about average pooling. They use average pooling. Okay, that's it. I think that's it. Okay. I say again. So one is they talk about this identity, but identity has consists of one important thing is 1x1 filter. Okay. So we start talk about this one. So we talk about ResNet here. So ResNet is year 2016, 2016年那个 best conference, ICCV best conference, CVPR best conference. Okay, and the other one is the NIPS. I'm sorry, N 忘记了 here NIPS, right? Good conference. Okay, and this is a backbone. So we talk about backbone. Backbone is for extraction, for classification. So both are important. And later, after ResNet, they have a ResNext. We have a DenseNet. They improve from the ResNet and based on their identity. So after ResNet, many people use shortcut. Shortcut means the identity. Okay, so ResNext, DenseNet also use this kind of identity things. Okay, but to me, I want, if you just apply this one, it's okay. But this already getting complicated. 这已经变复杂了。Complicated meaning it's not easy to improve, not easy to modify the network. So if you want to improve the network, you can use VGG or use ResNet. GoogleNet is complicated. Those things are complicated. Okay. Next one. So we already talked about the XNet. 刚刚讲 XNet 5+3, but XNet has only three maxima pooling. 1, 2, and last one, 3. XNet. And second is VGG, and we just talk about the important thing for VGG is they use 3x3 kernel. Kernel also called filter, so use 3x3 instead of 7x7 or 5x5. Okay, it's VGG. Okay, and VGG before VGG and before VGG here they use traditional neural network MLP, so it's 3 layers. But ResNet only use 1 layer. Before ResNet, people use more layers here, fully connected here, or use fully convolutional. Okay. So before we talk about ResNet, I talk about GoogleNet. Okay. So this GoogleNet, I do it this way. So here the Google input here. So here's only up to here. This one block. From here to here is one block. It's GoogleNet. Okay. So for each GoogleNet, here's just it's easy. I zoom in. So previous one is just extraction. Extraction. Okay. 糟糕。全部没了。跑掉了。哎，是从哪边开始没有？哦，刚刚也吓死我。好。Okay, so we talk about the GoogleNet. So this one big block, and GoogleNet has 3 big blocks. Total has 3 big blocks. The GoogleNet, and this one block. So they do training is they train this one first. After they train this one, they got a result. The classification here. So after this one, you got a result. And then they fix all the parameters. And then they copy this one to the second connection here. So what they did is for the input here, only the first one is 7 by 7. Why they do 7 by 7 is because at that time, the GPU is not so powerful. So the first one, they don't want to use 7 by 7, but they want to reduce a lot of image size to reduce the parameters. So the first one, they try to use 7 by 7. So after this one, no more 7 by 7. So what we will do is here. So that's commenting. Okay. So we have we have 1, 2, and 3, and 4. This 3, and then sorry, I'm wrong. Should be here. 这一张这里我刚刚弄错了，刚是这样子，这个错了。I do again, sorry. Okay. So this is one block from here to here. Okay. So for the inception of GoogleNet is this one. It's regular input, extraction, and then here, inception. Here is regular. It's regular one, just extraction, and up to here is a inception 1, inception 2, so A, B, and then inception 3, and then output to here, and fully connected, and softmax, and it got a result. Okay, so before average plotting, before here, we use VGG. Before we use something like VGG %, but here they use inception. So at this time, okay, 2 papers. Both papers are published at the same year. Both papers published on CVPR 2015，同一年出2篇这种 paper。那 VGG 就刚刚提到的，就是 DIP 这样子。GoogleNet, actually they say is this one. VGG say XNet is not deep enough, so they do very deep. GoogleNet say it's not only deep enough, it should be fat. So they do inception. So two difference. GoogleNet is not only a little bit fat, they also deep. Okay, so we back to here, the concept. So here before the same， 所以有时候你在出配你会发现哦，那个同一年有时候会很竞争，会有不同的派别，有人说这个好，有人说这个好，那怎么办？那一般来讲，学生是没办法判断，那就靠老师，老师就要靠功力，所以有时候老师会带错实验室方向，他决定这个比较好，就走了几年以后卡住了。对吧？跟公司一样哦，公司那边也一样，公司有时候要去判断要往哪个方向走。就我现在举例来讲，觉得元宇宙要不要走？台湾讲元宇宙，那你觉得台湾讲的对不对？ 对不对？现在台湾到处都要讲元宇宙怎样怎样怎样，那公司的人也讲哇元宇宙怎样怎样，但是有时候不要被公司的老板骗了，他们只是为股票而已，你懂我意思吗？所以你要用自己的纳力去判断。那以我来讲的话，我说元宇宙，我觉得不可能那么早发生。我不知道台湾为什么炒那么热，一直讲那么多。我个人觉得是不可能那么早。为什么？因为我 VR 跟我说，基本上元宇宙是 VR 跟 AR 嘛。那我一直讲从很早就讲 AR 比较容易，不是比较容易，就比较，因为它不用带什么东西嘛，用这样裸视看嘛。那美国那个飞机早就在用 AR 的嘛，就是那个战斗机上面抬头显示嘛，就是 AR，所以他们在军中已经很多在用了。那我在美国他们就在用，那我自己本身也做一些嘛，现在运动那些都有，所以这种比较方便的，所以我觉得我一直强调 AR 应当会很快就发生，而且会跟在手机上发生，因为这样就可以看得到了。只是 AR 就要找一块地，你要找一个地来让你站嘛。啊，那另外是一个抬头显示是另外一回事。那 VR 不是不要做，那 VR 因为戴起来很不方便，所以你没办法长久来戴嘛。所以 VR 你比如跟市场方面，你如果市场，我个人觉得 VR 你如果市场是往医院那边教学，这很好用；你往店那边也很好用，因为这短时间可以用这样子。那 VR 的市场重点，另外一个重点是就一样嘛，就内容嘛。你如果内容没有很多人来投入这个内容，你就看起来看了一次也是这个，2年后回来看也是这个，就觉得无聊，因为没有什么进展，也没有那么多游戏公司投入嘛，因为没有市场还没成熟嘛。那所以反过来讲，元宇宙到底就是会不会发生？我觉得那还很久，因为它要建立一个共同平台，要去人家去统一这样子。但是以公司实验室，它可能拨一点点的人来，因为它最主要是要占那个市场嘛。哦，所以这公司就像我们实验室很早，我做 AM 嘛，为什么要做？因为我看到这个一定要做，你不做的话，当你那个进步到一个程度的时候，你投进来你会追不上。所以有些是为了要，就不是赚钱，是为了要跟得上那个时代的潮流这样子。所以反过来讲，就是说我们也会遇到要去带学生要去判断说要往哪边走，这是一种对老师讲是一种长期训练。那当然这种就要去像我就是跟那些大公司大老板去谈去判断这样。只是运气很好，以前有在美国大公司有时候就是要因为人手有限，钱有限，你不允许你失败啊，所以你要常常去动脑筋，去赶快去修正。那我那时候在 startup 公司就有受这个训练，所以这个变成你对市场就有个敏感度这样子。好，那我们回到这一边好，所以那时候就这两派出来了。那一个很简单的判断就是说，东西如果简单好用，那当然往那边走啊，对不对？那所以你看这个 Inception，哇，这么深这么复杂，那对我来说当然不要用啊。所以那时候我就往 VGG 走嘛，很早以前就往 VGG 走嘛。可是后面是回来发现说，哎，Inception 还是有它的好处嘛，它结果还不错。那你要想，我如果整个拿来用，我很难改。那它好处是什么？好处就是 Inception 这里嘛。所以后面有人在改这里的东西，就那个叫什么 Atom 是不是那个东西？我忘记，就是有一点宽的东西，这边有，就是这我后面再讲，待会就讲一下。所以它好处是在这里，不是整个这样。Okay, so we back to here. So see, so this one in the global, okay, they have three blocks. This first block from here. So they 1, 2, 3, three exception. And here average pooling. They do average pooling, and then fully connected and output softmax. So this total is one big block. And after this training, they feel this result is not good enough. So they copy this one to the second one. And because this is already complicated, so they fix the parameters. They did not update the parameters. And they connect to the second one. So second one is the same, repeat, and they got a result. We call it fine tune. It's getting better. So finally, the GoogleNet has 3 big blocks. GoogleNet 最后是有3个这种 big block， 结果就很好，这样子。Now back to here. So for each one, what's the inception here? Okay, so we talk about inception. 所以我教你 GoogleNet， 我不是没教。那 inception has many generations, but I don't know how many generations. Probably 3 or 4. I don't know. 它有 inception 好几代哦 ，V1, V2 好几代。那 we talk about. Actually, I talk about here. Okay, so the first inception is this one. 我讲是这个哈，一个 inception 是这个。So first inception is this one. So that's meaning they feel if you just go one way, it's only one convolution, 3 by 3. They feel why not? We have a 1 by 1 convolution to extraction, 3 by 3, 5 by 5. Different filter to extract different information should be better. It's correct, right? We have different size of filter. We can extract more small local, medium, and global information. So they have a 1 by 1, 3 by 3, 5 by 5, and they extract the same map. And after the extraction, and they got a result. Okay. But they still feel, how about, because we already know maxima theorem, so how about try one more result? And the result is better. So let's try one more. This already there is a maxima theorem. So this result is good. Okay. 那这个要不要用？这个要用，不是不用哦。This is good. So when you do the later on, I teach you YOLO V4. When you see a YOLO V4, they have a in the lower layer they have a SPP. They have a 1 block SPP, only one. Is the same as this one. 那个有个叫我突然忘记叫 Atron 是不是 ？ATRON 这样子 Atron 就是一样，就把就one more and become more wider. But that's good. Okay, back to here. This first generation. Or say zero generation. And extension V1 is this way. The same. They try to improve the disadvantage of this one. So what's the disadvantage of this one? More parameters. Because this day is many maps. This is not only one channel, there are many maps. So this many maps, suppose there's 64 maps. So each one is 64 maps, 64. Output is 64. Oh, sorry, output is concatenate. So it will be 64 times 1, 2, 3, 4 times 4. Your input is 64 channels. Your output become 64 times 4 maps. So your parameter become many. So the next one is people think about how can we reduce the number of parameters. Here they say this one， 他讲很厚，意思就是很多 maps 啊，这里或是很多 maps。好， now back to here. So how can we reduce the number of parameters? They include 1 by 1 convolution. Okay, so that's meaning suppose suppose here I use this. Suppose here is 16 maps. 假设你有16 channel maps 在这里，16 right? So if you do this one, this 16, 16, 16, 16. So here you concatenate. Will be 16 times 1, 2, 3, 4. Become big. That's not good. So if I have a 16 channel here, I come here. What's the purpose for 1 by 1 convolution? What's the purpose for 1 by 1 convolution? 1 by 1 convolution is crossover. And they can increase or reduce the channel number. The purpose for 1 by 1 convolution, 1 by 1, 1 by 1, 1 by 1, 1 by 1. 1 by 1 only give an image, right? 1 by 1 only 1 pixel. So if one image use only one by one convolution, is useless. But you have many channels, many maps. So in this case, we have 16 channel or 16 maps. So you can use 1 by 1 cross 16. And then depend on how many filters you want to have. So actually, this is not 1 by 1. No. This is 1 by 1 times this one. So this one, the filter is 1 by 1 by 16 channel. This crossover 16 and times filter, number of filters. So if I filter is 8, they will become 8 channel. Here. Output is 8 channel. 这样听得懂吗？ Original 16 channel. If I come here, why we need 1 by 1 here? Because this actually is not 1 by 1, it's 1 by 1 by 16 channel. 16 channel here, crossover for 1 pixel. And then total, suppose total I have 8 filters here. 8个这种 filter， 那我就出来就是8个 channel， 所以我就 reduce 16 channel 变8个 channel。可以哈，我应当用4个啦，4个比较好，因为他不想让 channel 改变。We take a break and then I reduce this one, modify this one。我们先下课一下，好，再来。